So next one we are going to see about phototransistor. See, all these devices, if you know the basics of diodes and transistors, it is going to be same thing except when you are going to activate everything based on light. So phototransistor is a light detector which combines a photodiode plus amplifier. So when the phototransistor is illuminated, it permits a larger flow of current. So you know that a transistor has three terminals: emitter, base, and collector, right? So I am not going to give any input to base. I am going to give light in the collector base junction because collector base junction is reverse bias. Emitter base junction is forward bias. You know that these devices work in reverse bias only, right? So in the transistor, you have two regions. Emitter base junction is forward bias and collector base junction is reverse bias, and you have to pick the reverse bias region and apply the light there. So that is why they have chosen the emit collector base junction for applying the light. So same way you will be using a lens to focus the light on your collector base junction, which is reverse bias. So even though you have reverse biased collector based junction, these charge carriers, these light is going to produce more number of charge carriers, which are going to cross the reverse biased junction, leading to production in current. Leading to production in current. That is the operating principle of phototransistors. Okay, you can see the diagram. We have seen the diagram. It is usually connected in a common configuration with the base open. See, usually we'll be giving input to base in CE mode, right? But here we are going to leave the base open. I am not going to give any input to the base because I am going to give input in the form of light to the collector base junction. So I am going to use a lens to focus the light on the collector base junction. So although the phototransistor has three sections, emitter, base, and collector, the base is not used because I am not going to give input to base, right? So predominantly I'm going to use only two leads, emitter and collector. So base current is supplied by the current which is falling on the base collector photodiode junction. So definitely the operation is same. So as the light is going to fall, you will have production of IB, IC, and IB, and the relationship is emitter current equal to collector current plus base current. All these formulas, everything will be holding good. Only thing, I am not going to give any input to my base. Base is going to be kept open, and I am going to illuminate the light on the collector base reverse biased junction. Be very clear on that. Okay. So here also same way, when you don't radiate light in the collector base junction, you will have no photo current produced, but because of minority carriers, you will have the reverse saturation current IC naught. Okay, you will have the reverse saturation current IC naught flowing in the device because of minority carriers which are crossing the collector base junction. Okay, so that equation is same as your transistor. So IC equal to beta plus 1 into IC naught. When I'm going to give light, the additional photo current is produced, and that is given by IC is equal to beta plus 1 into IC naught plus IL. So this is the IL is the reverse saturation light produced because of light. Because of light intensity which is radiated in the collector base junction. Okay, so when you don't show light, it is you are going to have a reverse leakage current, or you can call it as dark current, given by IC equal to 1 plus beta into IC naught. When I'm going to illuminate or radiate the collector base junction with light, then the collector current is given by IC is equal to 1 plus beta into IC naught plus IL, where IL is the reverse saturation current produced because of light. So here also current in phototransistor will depend on how much intensity of light is falling, and it is not affected by how much voltage, reverse bias voltage you give to the circuit. So the VI characteristics is given here as a function of H. You can see when you don't radiate light, you have the dark current here. So you have the zero lux, the diagram corresponding to zero lux is called as dark current. So for higher value of lux, you can see the collector current is increasing, just like what we have in the output characteristic graph. It is increasing and then it will become saturation, it will become constant. So we can see as the illumination is going to increase, the current, photo current is also going to increase. And the scenario when you have no light, that is going to be called as reverse saturation current, or technically in photodiodes and phototransistors we call this current as a dark current. Dark means there is no light. So when I'm not going to radiate light into the device, the current is actually, logically speaking, current should not flow. But because of minority carriers, you will have very minimal amount of current flowing to the device. That is going to be called as dark current. The same way how we are using photodiodes, we have extensive application of photo transistors in high speed reading of computer punched cards and tapes, light detection system, light operated systems, reading of film soundtrack, production line counting of objects which interrupt a light beam. So all these different applications you have photo transistors, and these photo transistors will amplify your light. So major differences in photodiode, the reverse bias current is not of microamperes, right? That is why we said I need a device for amplifying this current into milliamperes. But in photo transistor, this amplification is done by the transistor itself. And you see the collector current is it is in the order of milliamperes. See, this milliamperes current is very sufficient for me to drive any electronic application, whereas microamperes current is not sufficient. That's why we said photodiode plus amplifier has to be used. But separately, instead of having a photodiode plus amplifier circuit, I have one phototransistor circuit that is going to help me in doing both the purpose. So it is also going to work based on light, and current is also amplified to milliampere, so that this phototransistor can drive other applications which work on light. Okay, so that is the main thing you have to understand in photo